So we have a triangle with 3 sides. If we're looking for bearings, we're looking for angles. So we're not specifically told to solve the triangle, but we are solving at least a portion of the triangle. Well, usually we have a couple of different options at our disposal if we are not thinking about using right triangle trigonometry, and this is not a Pythagorean triple, so that's kind of out right now. So we have the law of sines, or the law of cosines. To use the law of sines, we need a matching side and angle. And while we do have some angle information talking about going from Salt Lake City to Los Angeles, it is not that whole angle. What we do have is 3 sides. And when you have 3 sides, you are going to be using the law of cosines. Well, we've got our side measures, but we don't have this piece of information here about south and then go 34 degrees to the west. That's the bearing from Salt Lake City to Los Angeles. So for the purposes of this problem, I'm going to refer to this as angle S, this is angle L, and this being angle A. So from Salt Lake City, what I'm going to need is one of those compass directional orientations for me. Okay, so here's north, south, east, and west. I know that this bearing is 34 degrees west of south. So I would start at south, go 34 degrees to the west. I know that this angle here is 34 degrees. So as we look for this angle, I'm going to use the traditional representation of law of cosines and then rearrange it after I've plugged in, but feel free to use either one. So since I'm looking for this side, this angle I should say, I'm going to start with this side. So 11 squared should be equal to 9.5 squared plus 8 squared, the other 2 sides squared and added together, minus 2 times 9.5 times 8 times the cosine of this angle, which I'm calling angle S. So in solving for cosine of S, I will subtract 9.5 squared. I will subtract 8 squared. And since these terms are multiplying the cosine of S, to undo that operation, I'll divide by them. So I will divide by negative 2 times 9.5 times 8. That will give me the cosine of angle S. So on my calculator, I'm going to type all that in, and S is going to be the inverse cosine. Remember, don't write anything down. Use your answer button or something. And I'm going to find that angle to be 77.4 degrees. So this whole angle is 77.4 degrees. Okay. And I guess I'll go ahead and write it. I'm not going to write it in there. I'm just going to I'll be very careful to color code appropriately. So that angle is going to be in black. Well, let's turn our attention then to, okay, what about going from Albuquerque to Los Angeles? What does that look like? So I'm going to pick another color that's fairly light. I'll go with that. Not Carolina blue, but I could see how one might think it was. And I'm going to draw myself in another kind of compass set. I think I'll just go ahead and take it on over so we can maybe see how these things are related. I am looking for, we'll use green to signify go, that angle right there, because that's going to get me from Albuquerque to Los Angeles. So let's see what we're working with here. What has materialized in this is a little right triangle here that could be helpful to us. I know that this whole angle here, this here in black, remember, was 77.4 degrees. If I subtract this 34 degrees, just line it up nicely, that's going to be 43.4 degrees. So I know that this angle, we'll use blue, is 43.4 degrees. Okay, well, you know, you might be saying, how is that even helpful? Well, now I am able to find this angle. We'll use some purple now. Since this is a right triangle, 90 minus 43.4 degrees would give me 47.6 degrees. So I know this angle is 47.6 degrees. Okay? Well, you know, how is that helpful? We're getting there. It takes some patience. I appreciate your patience. So we will use an orange now. I really would love to know what that big angle is. Well, guess what? I now have a side and a matching angle. What does that remind you of? The law of sines. So I could say the sine of 77.4 degrees is to 11, as that 9.5 is across from there, the sine of Albuquerque's angle. When I cross multiply and solve, I find out that A is equal to 57.4 degrees. So this whole angle here at Albuquerque in orange is 57.4 degrees. Well, we know the purple is 47.6, so that tells me this little tiny bit, if I subtract out the purple, minus 47.6 degrees, that's going to be equal to 9.8 degrees. So that little tiny amount, let's make it, I'm running out of colors, whatever that is, grayish. So that tiny little amount in there is 9.8 degrees. Well, that happens to be the rest of this right angle. So if we go 90 degrees minus 9.8 degrees, what we have is, you'll notice that 47.6 has magically changed to 46.6. I realized that I had made an error. So if you were yelling at your computer saying, Miss Hall, stop, there's an error, I'm proud of you. But I have changed it, and so I think we're all good now. So that was 46.6 instead of 47.6. I do apologize for that, which means it didn't mess up the orange, but it did mess up this. It should have been 10.8 instead of 9.8. And then 90 minus 10.8 is 79.2 degrees. So this angle in green is 79.2 degrees. Well, when we're writing that as a bearing, we look at where we're starting from. We're either going to start from north or from south. From south is best here. We would start at the south and go 79.2 degrees to the west to get from Albuquerque to Los Angeles.